Okay, so here's question 2. Quite a simple one, but it's using a vector, and we've got an unknown in our vector. So we have to find out what A is in this vector. So let's think. So a particle of mass 6 kilograms is initially at rest and is then acted upon by a force R on a bearing of 300 degrees. So let's remember what a bearing is. So bearings, I always start from north. So that's going to be my north, and that's 0 degrees. I always go clockwise. So 300 degrees is going to be about there. Right, so that's which way my vector is going. So I've got A and 10J. So if we draw a triangle, that means that the vertical, the J, is going to be 10. So that's going to be 10. This is going to be A. Okay, but as you can see, I've got an angle here. So I should be able to work out what this is. Now, this is 300 degrees. If I go horizontally, that's 90, 180, 270 degrees. So this angle here is 30 degrees. Okay, now remember, if that's my angle, this is the opposite side, that's the adjacent side. So I'm going to use tan of 30 equals 10 over A. Okay, it's just simple trigonometry. I'm going to rearrange that so that A is equal to 10 over tan of 30. So 10 divided by tan of 30 gives me 10 root 3. So A equals 10 root 3. Remember, it's a surd, so there's no need to do anything with that. That is my answer for A. And that's an exact answer. Right, okay, now B. Now it says calculate the magnitude of R. Now remember, R is my vector. So this is my R vector. How do I find it? Well, that's Pythagoras. So for B, I take my two distances, A, which is 10 root 3. And remember, this is going in this direction. So A is actually minus 10 root 3 because this is going in the negative direction. Now B, so I've got negative 10 root 3. And I'm going to square it, and I add the other length, which is 10. 10 squared, and then I square root the whole thing to find the length of R. And when I do that, I find that R is 20, and I have to remember to include the units because R is the magnitude of a force. That's 20 newtons. So that is my final answer for B. Now I'm going to work out the magnitude and acceleration of the particle. So I know that if I want to do acceleration, I'm going to use F equals ma. So now I know what the force is because we worked that out. So my force is 20. And that equals to the mass, which I'm told is 6 in the question, times A. So let me just rearrange that again. And 20 over 6 equals A, which if we simplify it is 10 over 3 meters per second per second. Don't forget units. Okay, again, that's my answer. And that's C taken care of. Okay, now I've got D. D is asking for the time it takes for the particle to travel distance of 640 meters. So again, if we use SUVAT, so S-U-V-A-T times the thing I want. I'm told that S is 640. Okay, I've worked out acceleration. Acceleration is 10 over 3. and the initial speed was 0 because it was at rest. Okay, so I've got that. I think about my equations. I know that S equals ut plus a half et squared. So let's substitute in what we've got. 640 equals 0 times t, so that's 0, plus a half times 10 over 3 times t squared. So again, we do that. So we divide by a half. So we've got 1,280 equals 10 over 3 t squared. And we find that t equals 8 times root 6. It was roughly 19.6 seconds. And that's my answer for B. Easy. Okay, so the only important point here really is that as we've found A, and A is in the negative direction. My answer for A should be a negative.